Oh, sorry about that. I didn't see you there. Welcome back to Higher Theory Dev. I'm Johnny, and this is episode 3 of our Klipshow build series, where we're creating a monetized clip management platform for live streaming from scratch. For new viewers, Klipshow is a live streaming integration that allows viewers to pay real money to have approved social media clips displayed live in real time on stream. In today's episode, we're taking a massive leap forward from where we left off in episode 2 from our basic clip creation process. We're implementing the full iframe API from TikTok to preview any clips that are uploaded, and we leverage functionality that we've already built to deliver an experience that we're going to use for the public library of clips that streamers across the entire Klipshow network will be able to add to their private collection. You'll see us tackle some complex React state management, implement and review proper CSRF security measures. We'll continue to battle test our hybrid Rails and React integration, and as always, add comprehensive testing for both our unit tests and system tests using RSpec and Capybara. We also run into some tricky issues with Turbo that we'll go over and share any other bugaboos that we've ran into up until this point. I really feel like the application is gaining a lot of momentum, and we're about to get into some really fun features after episode 3, where we'll start to integrate our OBS browser view that the streamers will integrate into their stream setup to ultimately have Klipshow work, and the integration that will lead to the Twitch extension that we'll use for our streamers' viewers to interact with to redeem Klipshow tokens. Needless to say, there's a lot of fun and exciting things on the horizon, so without further ado, let's jump right in. In episode 2, we were able to get a very basic version of creating a clip and showing just the title attribute of that clip in our index action here, and as you can already see, we've made a lot of progress already since episode 2, but we'll go over everything. Don't you worry. Don't you worry at all. This is a lot closer to the mock-up that Claude originally made for us, and I think it's coming together pretty well. So what we're doing here, we're really leveraging the TikTok iframe supported functionality here to preview these clips. And my idea behind this was that we wouldn't have to add an additional OAuth connection to be able to, at scale, go and fetch all the metadata for these clips and save them. And then I also thought metadata can change, it can update, and that seems like it's not worth the effort just to try to keep a one-to-one connection between the social media source and the clip source. So I'm hoping that we'll be able to get away with this here. It seems to be working pretty well. So we have the iframe here being loaded from the platform ID that we're capturing, and we're going to go over that in just a moment. And then we're allowing the user to store their own title, and we're going to record the play count internally so that we can control that, and we don't have to worry about how many views or whatever is happening on the TikTok side of things. It's mostly relevant to us to have how many times that this has been redeemed, I think, be displayed on the streamer card instead of the actual TikTok metadata. We have the ability to enable and disable clips here. This is after it's been approved, and again, we're going to go over that process. This shows how many Klipshow tokens we currently have configured for this clip to be redeemed. So we're just playing around with that, and then we have a gear icon here that goes to an edit action. So we've got a lot of functionality to cover. Let's get right into it. Episode 2 left off on the create form here, and it just had a basic title that we were trying to use to implement bridging that gap between the back end and the front end. This is a pattern that I follow a lot of the times, particularly when starting something from scratch or even a new feature for an existing application from scratch. It's very important for me to get a small victory out of the way so that I can make sure I'm on the right path, and that's where we left off in episode 2, trying to make sure that we're not biting off more than we can chew, making sure everything stays tested as we develop it. So the next process was going through and getting some actual functionality dialed in. So in the add new clip here, we support the ability to take a TikTok URL from the top of a TikTok post here, just copy the URL and paste it in here. Now, what happens behind the scenes is we have some dynamic functionality that validates that whatever is in this input field here for the TikTok URL is accurate. It does match this pattern, which shouldn't change on TikTok's side. And what we're mainly after is this number at the end here. This is what we're going to store in our platform ID column on the clips, and I'm hoping that when we go to expand to Instagram and other social media sources to be able to add clips to, we can follow this same pattern. But for now, TikTok is working really well, so instead of getting hung up on details that may not matter for us with other social media sources, TikTok is doing really well with this supported approach. We're staying within the terms of service. The terms of use. So I feel really good about just having TikTok for now. So we'll go into how this iframe functionality is working first and how we kind of wired the Rails view things, which is how we left episode 2, to now this is being served as a React component. Oof, this is going to be a big episode. I need a bong hit already. Okay, now I'm ready. So we're still leveraging the new.html file now, but you'll see it's been slimmed down a lot more already. And I went back and forth a little bit on this during the development process. I originally had this set up to use just regular HTML in a very Rails-oriented way, and I was trying to keep it as simple as possible, but because we have some of this dynamic functionality built into the form, I went ahead and pulled the trigger on having the form be used in the context of a React component so that we would have immediate availability for handling stuff like validations and that TikTok preview URL. So it was a decision that I went with, and I think again, the reason that we're able to do this kind of stuff is we've built this to have a hybrid approach to ideally have the best of both worlds from what React can offer while having the dependency and everything with Rails that we really like. So we landed on making this a React component. We call it clip form. So in the clip form component here, we have at the top our methods to be able to handle the input when someone is entering something in that URL field. We're doing some conditional checks here to build out the body that's going to be sent to our controller. And this will change here based on if we're creating a new clip or we're updating an existing clip. And the way that we're able to differentiate that is if we have an ID on this clip object that we're getting from our props here, we can treat it as updating this, and that changes what the body will look like here. Or if it's a new clip, it's considerably different. So as you can see here, we're using this streamer clips attributes for a new clip. And the reason for that is when we create a new clip, we're actually creating two records. If we refer back to this diagram that I made that tried to explain the has many through relationship that we're using here, we'll see what I'm talking about. So we're going to have a clips table, and this is going to be where the potential for individual streamers to have multiple clips together kind of starts, right? So we're creating the clip, and on the clip, we're going to keep the platform ID, which is that long number in the TikTok URL that we're after, the platform as a string. So we will hopefully be able to use this interchangeably with Instagram, X, and any other social media platforms we may expand this to in the future. And then we have this shared by, which is a foreign key on whichever record actually uploads this. My vision for this is that it will either be a viewer or a streamer. So we're storing that as a string on the clips column here. And if you notice, I did have to just change this because it was integer and that was incorrect. So shared by type is going to be a string, and that's just going to hold the class name of whoever uploaded this. Again, I'm trying to future-proof ourselves for features that I have a good feeling that we're going to want to use. And it's really crucial to think about that early on, because as you'll see, we already had to go back and change some stuff in our migration. We're allowed that luxury in the current place that we're at because we don't have this deployed to production. There's no one else on our team that's using it, so we're able to take advantage of that. But normally that is not something we'll have the option to easily do. So I'm really trying to be cognizant of whenever we add a migration before it gets pushed into version control or deployed to production, that it actually is encapsulating all of the columns that we need. And that's really only a problem when we first start. As we go and we've established the core attributes of our columns, we should be okay. So when someone creates a new clip, they're creating this record, and then to have it available for themselves, we're also creating this record, and we are making sure to assign it to the current logged in streamer. Since we're creating two different records here, it creates a bit of a weird issue when we're submitting a form that seems like it's only for one resource. To the user, they're not going to really know that this is the relationship that we have working in the backend. So this streamer clips attributes comes directly from Rails. Rails allows for us to create both a parent and child record all in one request. And this is a really nice way of going about this approach, in my opinion, because it allows us to handle that in one request. We don't have to make two requests. We don't have to have additional logic to create another action like we did in the controller. And for error messages, for example, if there's something wrong, since episode 2, we've added validations for some of these fields, and we'll go over that in a moment. But if we had any errors on, for example, the streamer clip, if the title didn't get included, we can easily, through Active Record, have those validation error messages displayed, whether there's a problem with the clip itself or with the streamer clip that we are trying to cascade down after this gets created. Another thing that this allows us to do is it will not create a clip record unless the streamer clip record can be saved, which is again what we want. We cannot have a streamer clip created without a clip record. required. And Rails handles that for us very easily by adding that option on the model, and it just kind of works out of the box. It can get a little funky, particularly with the form and trying to reuse the form with both the create and edit option, but this seems to be working pretty well here. We may tidy this up in the future by creating like a JavaScript wrapper or something like that around this, but for now it seems to be working, so we're just going to roll with it. Along with the actual body, we're having to differentiate the HTTP method that we're going to be using, because those two different methods on the controller, whether it be the create action or the update action, they will need to be sent via different HTTP verbs. So we're just differentiating that again by using a ternary operator. If we have an ID, use the put method because we're doing an update action. If we do not have an ID, then use the post action, as that is going to be the create action. We're following a convention here with our error messaging, which you'll see in the controller next. So if there's any errors on the response that we're getting, we're going to set that directly in our state, and we should be able to programmatically fetch that from the response by including any active record errors that may have happened from this request. And then a big thing that we added and had to figure out is the visit method. This is coming directly from the hotwired turbo package that we installed in episode 1. And from my understanding so far, the functionality of this is to not trigger an actual page refresh. Normally you would put like window.href or whatever here, and that will cause the entire page to refresh, which is not what we want. The visit clips here is automatically handling replacing the turbo frame that this is coming from with the content that it needs to from the clips response. So we're using visit here. It works in conjunction with that turbo frame tag that we have on the dashboard that we went over, I believe, in episode 2. So that's crucial functionality that we had to work out. And then we're just trying to have some default error messages here in case something goes wrong that is beyond the active record errors that we may get from creating this here. We're also handling some other kind of nice state stuff. Again, this is why we chose to use React. It's just really easy to do this. We can disable or change the submit button within this entire flow, and with just pure Rails that would have been very difficult to do, and it can get very clunky very quickly. And we basically copied from the form here what you would normally see in the Rails view for the form. We're just sprinkling in some nice stuff that we can get with that reactive state management that we have by using like stuff like this. If we're submitting, we're going to put the submit button as saving. Otherwise, we're going to have a save clip display. It's just little nice things like that that make going this approach worth it. So in order to get all of this kind of stored in the React version of things, we start out with passing in our prop, and this is going to be essentially the same thing that a normal form for Rails method would take in, and this will be either an instance of a new clip or an existing clip, and we're setting our current clip equal to this here. And again, we're doing some kind of checking to see if this is a new clip or a existing clip. And because this is kind of scattered everywhere, I feel like there's going to be a better way to have this functionality kind of sorted out, which we may go over in the future. But at this point, I'm just kind of in MVP mode. I want to toe the line on what we can do that won't leave us with too much technical debt while still moving the ball down the field with our application. It's super important to do that. And although optimization is very, very important, and we want this to run well and we want it to scale, it's also very important for this to see the light of day. And from my own personal experience, that's in jeopardy the longer a personal project takes just innately. So if the clip has an ID, we should be able to just use this object to initialize all of the properties here that we can have show on the form. If it's a new clip, we're going to initialize it here with some default values to make sure that those validations should pass on the front end. And we're trying our best to make it so that the form cannot be put in a state that is invalid. So this covers both the existing and new clip functionality there. We're using this TikTok valid flag to validate whether or not the TikTok URL loaded. And that's another aspect to using the TikTok iframe approach that we can benefit from. Instead of having to do some fancy HTTP requests in the back end or anything like that to see if the URL that the user's putting in is in fact valid, it should cover most use cases by just leveraging the iframe from TikTok, loading in the URL that we're able to derive from the user's input. And if the iframe itself loads, the message API that TikTok uses for the iframe will trigger a player ready event. And it looks like that only gets triggered if the video actually loaded, which is exactly what we want. So we'll get into how the TikTok preview is working now, because it's actually fairly important, I would say. So we have this TikTok component. We're only wanting to display it if there is a platform ID, because that's what this needs here. We're requiring an ID prop, and we have a player ready callback that we're using for this exact functionality. So we have a player callback function, and all it's doing is just setting that TikTok valid URL to true. And once that TikTok flag is set to true, when it comes time to actually submitting the form, we have a check here that makes sure that we're not even going to attempt to submit the form if somehow we were able to get an invalid TikTok URL, missing a title, a status, or a price. We're just not going to submit the form on the front end. In our TikTok preview component, it's fairly straightforward. It's mainly just using an iframe with the attributes needed on here to make this load. I had to mess around with some of the sandbox and allow attributes to make this work. So this is the current configuration that I have working. And then it handles our loading state for us. Right now, we're just displaying a simple loading, in text. We may change that to be a spinner, but this illustrates that this is kind of handling everything. And then we have a fallback here if there's no URL, which I don't think that's actually going to ever get rendered. But the idea here is that we can feed this component a TikTok ID and we can have it load that iframe. And this is the exact component that we're using in our index view to display all of the clips. And it loads differently, like one iframe will load and then another one will load. But I think that's a fair compromise for the functionality that we're getting in being able to adequately preview these clips and not have to worry about any additional functionality with generating thumbnails or anything like that. To illustrate how this works, I just copied another TikTok URL there, and the event listener that we have hooked up on this will detect the change, parse it as a valid TikTok URL, and then load that TikTok preview component, and this is the result that we get here. By default, even though we have a valid URL in here, the save clip button is disabled. The reason for that is we are requiring that there is a title on the streamer clip here, which is a column that we had to add to our migration, which we'll go over in just a moment. So let's add a title here. We can keep the status and everything the same. We'll go ahead and save, and as we can see, we are redirected back to the clips page. And like I said, sometimes the iframes will load differently here, but I really don't think it's that big of a deal. We got that nice toast message, and this seems to be what we need it to be. So in this pending state, we have a few different options here. And this again is another thing that we're able to handle easily by having this in a React component now. So we're able to approve and reject this directly from the dashboard. And what happens behind the scenes is an Ajax request. And this is another thing that I played around with, trying to keep things simple with Turbo, but the only functionality that I could get going was having a nested turbo frame for each individual card. And what this would do on approve and reject is it would keep all the other content static, but it would cause this iframe to reload. And I didn't think there was a way around that. Since we have the card in the state that we want in regards to the iframe being loaded, there's no reason in my mind that we can't just make a simple Ajax request for a better user experience, not having to go to a different page or to see the page flicker or anything like that. So if we click reject, for example, it will immediately update the tag, and we're getting that from the response from our controller. And if the request is successful, we're just replacing, very similarly to how we're doing in the form, that clip object, and the clip object status gets updated as a result of that action. So all of that happens asynchronously, and I think it provides a pretty sleek interface for this. In a rejected state, they can easily do the same thing with approve. They can approve it and the toast message shows everything is fine. Same thing with enabled. They can enable and disable. So that's why we have that hybrid approach. Turbo will only get us so far, I think. And then for edge cases like this, I think just going the simple asynchronous JavaScript approach is totally merited and viable. To go over how that works on the streamer card specifically, we have the streamer clip card component here, and it's mainly leveraging this update and save streamer clip function. So this ultimately makes a request to our streamer clips endpoint, which we haven't gone over yet, but we will in just a moment. And this is always going to be a put action because in this context, the clip is already saved, so we don't have to worry about checking to see if it's a new clip or an existing clip. And then the two different attributes that we're allowing are just that enabled and the status. So the status gets updated from the approve and reject buttons, and then the enabled gets changed with that toggle switch. And then we're just using React set state here to set the response, which is giving the current version of the streamer clip after this action has been performed from the database side of things, and we're presenting it to the user. So what this will do is if the save action completed, the user's interface will be updated, giving them confidence that their changes actually stuck and will persist. There's been a lot of different applications that I've run into where the state gets updated indicating that, oh, the save actually went through, but you refresh the page and it's back to its old state. So following this pattern, I think is really good as it keeps that state between what's valid in the database and what's accurate on the front end consistent. This ksfetch function is from a ksfetch service that I created, and this is what I plan on wrapping all of our XHR or Ajax requests that we're going to make throughout the app in, so that we can have have ultimately one central place that all of our requests are being made from. And if we ever need to make any tweaks to the default headers or anything like that, we should be future-proofing ourselves by making sure that we're using a pattern similar to this. In the ksfetch file, which I have under shared in the JavaScript directory, I am just importing the get CSRF token, and we'll go over the CSRF token in just a moment. I misspoke, I think, in episode 1 when I said we will not be using Rails CSRF tokens. We actually are going to leverage that as another layer of security with making sure that the requests that we're accepting on the controllers have the best likelihood possible of coming from a view that was rendered with Rails. But this is another service that is basically getting that from the meta tags that are rendered in the layout of our views, and that's another aspect to how the CSRF token works that we'll go over. And then we're just setting this up as a regular wrapper around the native fetch API, and we're giving the ability to pass in options, the headers, and by default, each of these requests will have this X CSRF token placed in it, which is coming from the page. So this is our way of bridging that gap between Rails saying, hey, any request that we take in the form of a put, patch, or post request needs to have this CSRF token on it, because our functionality that is currently enabled shows us that we need to validate that as being what we sent over the wire to make sure that what comes back is coming from the right source. In order for us to be able to leverage the CSRF tokens and making sure that they're being generated correctly, all we need to do is include the CSRF meta tags helper in our layout, which is what we're doing here, and ultimately that will render 2 meta tags onto our page. If we load up a browser here and open DevTools, we will see that we now have a CSRF param meta tag and a CSRF token meta tag, and that's what's coming from that helper method there. This is what we're able to target with our ksfetch service to be able to collect that and include it in each of the requests by default in the headers. So let's go over what a CSRF token or a cross-site request forgery token is and why it's useful and why we're using it. So I'm going to start with the example of if we didn't have this type of mechanism in, what this would open us up for in the form of cross-site scripting, or XSS. You'll see it a lot of the time. So for example, let's say a client is going to the bank, to their bank's website, and they're using their login info, and the bank comes back and says, sure, we'll set sensitive info in the form of a cookie on your browser so that in the future, if you make any requests, we'll know that it's you because you have this cookie that includes sensitive data. Let's then say that a browser goes to a malicious website where they're trying to implement this cross-site scripting attack. How that might look is having a request included to them with their cookies stored from their bank's website that they can then use and capture it in the form of a hidden form on a website or something like that. They can capture this sensitive info. Then they have the ability to send it directly to your bank. And as far as the bank goes, this request is coming from the same person this request is. And what a CSRF token does is it uses that secret key base, that master key that we were using when we went over how the credentials work in Rails. And that's a token that gets stored on the server and is not presented to the client, which gives us a huge layer of security with being able to use that to sign a string that we can then use in the form of a cross-site request forgery token. And when we're using that in the form of the browser and having that sent back and forth, each time we're getting a new CSRF token sent because it's only valid for each individual session. And we know that it's valid because it's signed from the same source that we got it from in the cookies. And the token itself won't have any valuable information on it. So if another cross-site scripting attacker were to try to collect that cookie and try to send it to our Rails server or to a server that's using cross-site request forgery protection, then they'll easily be able to see that this token that they're trying to pass in has already been used, it's expired, or it's been malformed in the sense that they've been trying to spoof it or something like that. The mechanism that checks that based on that secure token that is only stored on the server, we're able to defend against that and make sure that only requests that we trust are ones that are being processed in our application. And then here we're doing a few things. We're getting the data if that came back. If parsing this JSON causes an error, we're going to set our data variable to a default object, which is going to follow a very similar convention to the flash messages that we saw in the Rails controller side of things. This is going to be following that same convention of being able to digest that. And the idea behind this, as you'll see in just a moment, is whether we're having the initial HTML load or a turbo request made or one of these Ajax requests made, the interface and how those toast messages are being displayed displayed should be pretty consistent. And so that's what this pattern allows for us here. If something happened in being able to parse the JSON from the request, we're covering our bases by setting it to at least a default message and putting that error message that got raised in the JavaScript side of things in the alert that will ultimately get shown in the toast message. And then here, if everything's going correctly, if there's a flash message in the payload that we just got back from the server, we'll go through that. And this is the equivalent in JavaScript of going through either the notice or alert type flash messages and making sure that they get displayed. And we are doing that in the form of broadcasting a custom event called show toast. And we'll show you in just a moment where the toast component digests that and ultimately triggers the React Toastify method to show the toast message. So this is just doing a little bit of setup for the payload that will get sent in that event from who is listening to it, which is going to be that toast component. And then we dispatch it on the document. In our toast component here, this is where we're actually using the toast container now. We've modified this from previous episodes, and we were having the toast container accidentally included multiple times in our component renderer function. So following this pattern, hopefully will be a bit better, and we'll show you how this bridges the gap between this React component and being rendered in the Rails view as well. And there was some kind of tricky stuff that we had to get going with Turbo to make sure that once this component loads on the page, it's not being remounted. The reason that's important is when we do these kind of event broadcasts and try to follow the pattern that we're laying out for having these toast messages displayed, we need to make sure that we're not losing reference to this toast container element. If it gets re-rendered, there's going to be a new toast container on the page, and our toast messages won't display as we expect them to. So here, when this component mounts, we're adding an event listener for that show toast custom event, and then we're running this handle toast event function. And the reason we have this in a function is so that if and when this component ever unmounts, we can have a cleanup method called, which will remove that event listener. Whether or not that'll actually get called, I think is beside the point. Regardless, I think it's good to follow this type of pattern of cleaning up your event listeners in the event that you don't need them anymore. And then if we ever change these props, so this is only going to happen on the initial page load, I believe, we're going to handle the toast event by default. So this will cover us on regular HTML event loads. And then in our handle toast event, we're just doing the same thing that we're doing manually here. We're just having the message parsed from the payload, which is what we put together from our KS fetch service. And then toast is being called based on the type that we're sending in, kind of another clever way of doing that so that the right method on the React Toastify package is getting called. And then we're doing some styling here, and the conditional is if we're showing a success message or not. So this is how the toast, kind of the inner workings of it, function. And then to get it working on the Rails side of things, we are just including it in a partial here under the shared toasts file, which you can see here is just under app views shared underscore. It's following that underscore convention. Again, that's a Rails convention that we have to follow in order for this to work. And then all we're doing in there is rendering that React component, and that's that toast component. And this is passing in the notice and alert flash messages here. So if the page just loaded and it has a notice or alert to show, this is how those get rendered, and that's how we're taking care of those types of requests. And then the last piece of the puzzle that I'm hoping I had to figure out to get this working is the data turbo permanent attribute here on the element that ultimately wraps this. When a turbo frame request happens, it also updates the layout, and that's how we're able to get that functionality of having the right link highlighted or set to that active state even when we're not having a full page load. Turbo automatically knows that that's the layout and needs to be replaced with the HTML that it just got from the response that it made. What this is doing here is telling Turbo to ignore replacing this element, which achieves making sure that this component stays mounted regardless of if we just made a Turbo request or initial page load or an Ajax request. Any which way that we make a request, we should be able to support that same convention of using those flash messages, and I think that'll be a really good thing that will serve us throughout the rest of the build here. I mentioned earlier that we had to change some database columns in our migration, and we're able to kind of cheat by fixing this now because of the circumstances that we're in, but I cannot stress enough, it's important to differentiate being able to do this now in the early stages of the development versus when this is actually in production and other people are working on it. So you can see here by the git commit messages or the git difference here that we added a few columns, and this kind of came about as I was building this functionality out. I wanted to make sure that we had everything stored in the database that we plan on using, even if we're not going to build features out for it right now. So we added a play count on the actual clips table, and my thinking on that was when streamers start to go and look in the public library of clips in Klipshow, they should be able to sort that based on play count. And if that's a column that we keep track of and can have a counter cache on and be able to index and sort and all that kind of thing, we would be able to allow the user to sort clips based on that. And I think that'll be really helpful in the future. So I added play count now. We're adding an index to that since we plan on doing a lookup or a sort based on that play count. We also added that uploaded by and uploaded by type here, and we're setting the default to streamer, setting an index on that as well because we may want to sort based on the creation type in certain places. And then on the streamer clips table itself, we added an enabled option. So this kind of dawned on me when I was building out the status dropdown, which is a feature that we'll build very shortly. How are we going to differentiate a rejected versus a disabled clip? We don't want a disabled clip to be rejected necessarily, so it kind of needs a Boolean column, which is why we added that. So we have a Boolean field, an index goes on that as well. And then we have a play count on the actual clips itself for the local to the streamer, since we're adding it to the streamer clips table. And what this will do is allow us to show the analytics for the streamer side of things and also give a streamer's viewers the ability to see which clips are the most popular or not. And then we also added a title on the clip itself, and then you saw how that worked in the form. We're getting that on initial creation, we're getting that from the user. And I was kind of torn with how we're going to handle that kind of metadata and that kind of thing, and started to go down the rabbit hole of setting up OAuth for TikTok to be able to have these people link their accounts and make API requests to get that metadata. And I just don't see it as being worth it. And I'm very thankful that we're going that route because it's a lot of added complexity that I don't think is going to get us much victory. That iframe API should carry us very far. It's worth noting that because this kind of goes against the normal convention of things, in the event that you would have a column added to a table with a app that's already been deployed to production and has other engineers on it, you'd have to create a new migration for each change. And that's exactly the reason that I'm going this route here, is because if and when anybody else works on this, they won't have a bunch of extra migrations that are adding and removing columns that ultimately didn't get used. So in order for this to get updated in the current state that we're in, we have to delete the DB schema file. But before we do that, because we're using Docker, what I found to be most effective is to use the Docker down command to make sure that any connections to the database are terminated. Then I restart the Docker containers so that the Postgres container and the web container that has the Rails code on it is actually back up and running. Once I get to that point, then I delete the DB schema file, because if you load the containers by default after you've deleted the schema, it will rewrite the schema with the current migrations that are set up, and that's not what we want. So after the containers are back up, delete the DB schema file, run that DB reset command that we set up in our Docker dev file, and what that will do is delete the database. It will see that there's no schema to go off of, so it will run each of the migrations from start to scratch, and it will pick up these changes as if this is how it was initially. And again, we're only able to do that because of the current state of things, but that's what we did to get the migration cleaned up, and we saved ourselves from not having to generate another migration. And migrations can get very out of hand, so it's good to be cognizant of that, I think. Let's go over some of the stuff that we're doing on the streamer clip. As you can see from episode 2, we've added a bunch of stuff here. So we're adding this before validation hook. This is something from active record that we get, and we're able to use those methods again because we're inheriting from application record, which is just a wrapper class that we have in our models file to have all of the resources by default inherit from. So before validation allows us to set that status. It allows us to set active, that Boolean column on the streamer clip, if the status is active. So this allows us to not have to specify another input for the user to submit. It's just kind of a convention that we're following. If it's approved, it's also going to be in an active state by default. You can change the active state separately, but initially on that approve and reject process, it will automatically put it in active or not if it needs to. And we're using this in order to make that work. Default scope is another active record method that we're using here, and that's fairly self-explanatory, I think. Just by default, when we aggregate all of the streamer clips, we're going to order them by their created at timestamp in descending order. So this should have the newest clip at the front of the line, and then it goes from there. And we may change that in the future. It's just something that I added while we were working on it because I think it's a little nicer. Our scopes didn't change here. We haven't used these yet, so maybe we'll erase them, but most likely we'll be leveraging these when we build out the functionality to filter the clips. And then a big benefit from using active record, or kind of Rails in general, is the validations that you can have on the database records before a database transaction is actually made. So we're validating that the title, the clip itself, the streamer, the status, all of them are going to be present, and we're able to declare them on one line just like that. We're going to make sure that the title is no longer than 255 characters, and we're going to make sure that the status is one of the approved statuses that a streamer clip can have. tab. And the reason that this is necessary is we're setting those in a select on the form itself, but you have to remember people can deviate from that and make a request directly to your server if they reverse engineer how those requests are made, which is an easy thing to do. And this gives us another benefit to make sure that only statuses that we approve will make its way into the database, and it reduces the margin for error for monkey business with people trying to break something in our app or something like that. And then with price, this is another kind of just nice thing. It's a declarative way of indicating that we want to validate that the price column is greater than or equal to 1. So this indicates that at least one Klipshow token will be required to play each clip. And then we're having to do a little bit of monkey patching here on the as JSON fields. And the reason for that is because of the relationship that a clip and a streamer clip has. The streamer clip itself does not store that platform ID on it. It doesn't need to, because all of the central source for that is going to be on the clip model. And we need both when we're working with streamer clips, also with clips. So the easiest way that I found to kind of make sure that we're handling that is by overriding the as JSON method on the streamer clip model here. And what this allows us to do is insert some properties that Rails wouldn't normally include on this record for us. The reason for that is we're only going to get JSON on the columns that we have for the model that we're calling it on by default. And then this is including some extra information from the parent clips that we have. And so far that's working. We may run into an N+1 kind of database optimization issue with this, but we're not to the phase yet where we can adequately start optimizing things because the core functionality isn't completed. So another thing to keep in mind is, yes, this could cause an N+1 issue, and that's a bad practice and bad for performance. But for now, it is working. We're going to be mindful of that. And once the MVP is built, we can scrutinize this a little bit heavily, because the time that we spend optimizing this stuff is less likely to be wasted, because if it works, it will maintain the original functionality that we need to keep in order for the MVP and beyond to work. And then this set active here is just coming from that before validation method. And this is a private method. We only need to call this within the model itself. And this is just doing that, setting the enable to true and status to approved. One of the bigger struggles that I've had getting Klipshow to this point has been some of the turbo stuff, and specifically getting the toast messages working across different types of requests. And I wanted to go over what I currently have working and how that's kind of playing into everything else as well. So in our component renderer file here, where we were normally just using the mount components on the DOM content loaded, I added 3 more different event listeners to mount our components as well, because what I was running into was when we started using that React component for the form, it wasn't rendering on some of the requests. And the reason for that is it was getting rendered into the HTML, but the React library wasn't being called on that markup to actually make it render as a component. So to get around that, we're hooking into these 3 turbo specific events that make sure that our React components are going to get rendered, whether it's the initial page load or a subsequent turbo frame request that we need to replace. Something else that we ran into with this turbo frame kind of request stuff is our feather icons. We went over in episode 1, I believe, introducing feather to our application for all of our icon uses, and it's been working for everything that I've needed so far. So hopefully we'll be able to stick with it. In order to make sure that that feather.replace function gets called, this is the solution that I came up with, and it hooks into the same turbo and DOM content loaded event listeners that we're listening to for the React components. And what that does is it will create a new mutation observer, and a mutation observer will monitor the DOM, and if any changes to the DOM happen, we'll be able to tap into that and run our function. So we're using the request animation frame here just to try to be diligent with our resources, and having that called when this new mutation observer gets set up, and it gets set up when any of these event listeners get called. And we're just including that in the index.js file for our dashboard layout that we went over in episode 1, and we're importing that, and upon being imported, it will run those event listeners and hook into that functionality to make sure that our feather icons are being replaced as we need them to. With the addition of all of this functionality, we had to add a few more resources to our routes here. So on the streamer clips resources, we added the update, edit, and destroy actions. And those are all shown here. So the edit is for the actual form, and that initializes that streamer clip that we're sending to that React component. The update action, which can respond to either an HTML request, and that's handling the turbo side of things, or that JSON request. So if we are making a request via Ajax with that enabling or disabling, that's where this response comes from. And we're following the same pattern throughout here. It's important for actions like this is a good example here for destroy. We want to make sure that anytime that we're actually going to be calling a destroy or an update on a resource, we're scoping it to the person that's responsible for it. So in that case, it's going to be our current streamer, and that gets authenticated through our authenticatable module that we went over, I believe, in a previous episode. And we're making sure that although they're sending an ID in, we're still going to make sure it's a resource that actually belongs to the current streamer. We're not just looking up any streamer clip with that ID and trusting that they're not trying to update or destroy somebody else's streamer clip. And we circumvent that by just making sure we're always scoping it to the right owner. And that's what we're doing here. With the proof of concept out of the way, proving how we can get all of the React components and the Ajax requests and Turbo working with this minimum functionality, it's time to step it up a notch and implement this relationship between a public clip library and your individual private collection of clips. And so in the clips link here, we still have it as /clips, and these are the streamer clips that we've been working with, but now we have a little bit more functionality going on. So the first thing that we have is we've added a link up here to a clip library. And if you look at the top here, this goes to /clips/library, and all of these will be those publicly shareable clip objects that will show up in this list when any streamer creates a clip and has specified that the clip they're creating can show up on this list, or what we call it is the shareable column on the clip model. So in the clip library here, we already have it set up to display the TikTok previews. It's the same component that we're using in the streamer clip side of things, and we're showing that play count. This is going to be different than the streamer clip play count because this will be global for all of the clips. So whenever a streamer clip gets played, it will have its parent clips play count incremented so that we can have the ability to sort this based on maybe clips that are going viral or that are trending or what have you. So that's the intent there, and that's what that's going to look like. And we added a component here to be able to, all in line without having to go to a new page, add this clip that you can preview through that TikTok iframe to your own private collection. And the experience to do so just requires you to set a price, minimum of 1 Klipshow token. After you go next, you have to enter in a title. So this can be anything. And then you have the option to go back and cancel. And behind the scenes, you can see that we did not have to have the iframe re-render. It didn't show that loading animation or anything, because in the React component that I will show you in just a moment, this is just hiding the element that's wrapping the TikTok iframe. And that allows us to make sure that the iframe stays loaded and we can toggle back and forth without having to disrupt the UI too much. So going through here and having some clip added. So if we just set our clip here, the save button becomes enabled again and we can click save. This will take it off of the list now of clips that will show up in the clip library. So if we refresh the page, this clip will be missing, and an easy way to determine that is we have 2 rows right here. If we refresh, we should just have 1 row. We also saw our nice toast notification there, and I think this is a pretty solid and straightforward user interface. So to prove that the clip library only shows clips that you don't have in your current library, we'll go ahead and refresh, and we can see that we just have these clips now. And if we go to our My Clips section, the first clip that we see here, because we have our default scope to be ordered by created at descending order, this will show up first, and we see everything else that we have from what we've been working on up until this point. So a quick rundown on the changes that we had to make in order to facilitate all this functionality. It's a little squirrely with having to deal with this clips URL that we want to go to our private streamer clips library. I don't want streamer clips in the URL. That seems counterintuitive, I think. So that's why we're kind of deviating slightly from this resources convention. And Rails gives us the ability to easily do that. We're not pigeonholed into just using the predefined methods for defining routes. It's nice to follow that convention, but there's always going to be edge cases, and this happens to be one of them. So we're explicitly saying that the clips URL is going to go to the streamer clips controller on the index action, and the clip/library will go to the clips controller on its index action. This will give us an easy way to differentiate the scope that we need to load of the collection of clips or streamer clips in the view that's going to be rendered for these different endpoints now. So the functionality that we had before in the clips controller has moved into the streamer clips controller here, and we're adding a few different things. So I'll walk you through this. So the index action here, which we just added on the streamer clips controller and is correlated to our new route entry here, here will take a look at the status that we're passing in the get param, and it will check to see if it's any. It will just load all of the current streamers clips. Otherwise, we can go ahead and take advantage of those scopes that we had earlier. The remaining statuses here all have corresponding scopes on the streamer clips record. And then in the clip controller, we're now simplifying its index action to show all public clips that have that shareable flag on and that is not in the list of existing clips that the streamer currently has. And the notation that we're using for that currently is this right here. So that is how we're differentiating now between a streamer clip and a regular clip and their corresponding index action. Inside of the streamer clips index.html.erb file, the two things of note here is the clip tabs that we're now rendering here and a clip filter React component. And the clip filter React component is this right here. And what this allows us to do is drop down and select any of the statuses that we want to show, and it will automatically reload the page with that status pending in the URL. And in that clip filter component, it's very straightforward. All we're doing is setting the initial status to whatever may be in that status get parameter. And then we're using that hotwire turbo visit method to have the page automatically have a turbo request sent and update just the turbo frame for the dashboard frame that we're using there based on what is in the get params. The clip tabs here is this component at the top, and we're rendering this both in the streamer clips index view as well as the clip index view so that we can easily navigate between them now. And that partial is just very straightforward. It just has those two links and the icons that is needed. We're using the link to helper there for that, making sure that data turbo is false because as of right now, we don't have a nested turbo frame for this to load in. And you'll notice a little bit of flickering, particularly with the icons when we currently navigate between the two. So we may introduce another turbo frame to circumvent that, but for now this is working, so we'll leave it be. If we didn't have the turbo false on right now, we would have to adjust the controller to make sure that we're able to respond to a turbo frame request. As far as the actual React components for each of the clip cards now, we have two different ones, one for streamer clips and one for regular clips. We're just calling that streamer clip card and clip card respectively here. And I'll give you a little side-by-side comparison. We're still using the TikTok preview, and in the clip card, we're using this show actions component, which is nested in the card actions file here, and the index is the actual streamer card here. And the reason I like to follow this convention is anything related to the card, like this example here, where it's managing some micro state within the card component, we're able to just include it naturally here. And if we needed to have another folder to have it kind of nested, we would have the option of doing that as well. I don't like to go more than like 1 or 2 levels deep because it can get a little bit complex, but this is a pattern that has usually been pretty nice for me. And so we're using that here to make sure that we're able to get that functionality of going through, setting the token amount, setting the title, and ultimately making that Ajax request to the controller that will save the streamer clip from the clip that we're adding it from. And it's inside the actions component here that we're actually making that request with our ksfetch function. And as I was going over that, I just noticed that we need to update this slightly. We modified our ksfetch function to be able to return both the data and the response so that in situations where we want wherever we're making the request coming from to handle the validation, if there is any, we have the option of doing that. In this case here, there's not going to be any validation. It's either going to be a pass or fail situation. So we're using that here by checking to see if the response is okay. If it is, then we're setting that state that is tied to the component that makes your clip has been added to your library or whatever it shows there. That's how that works there. Otherwise, we'll just set the component to the title state, which is the initial state after you set your price, which is the last state that you'll be able to kind of modify before saving the clip. And because we have error handling in our ksfetch function, I went ahead and removed that try catch block because I don't think that we're going to need it here. I think we're handling this correctly, and we'll leave the toast notification for any other errors that raise that are unexpected to be dealt with from our ksfetch service. The only other thing I can think of note here is we went ahead and added kind of an overflow functionality to the dashboard here so that we don't lose our sidebar and the sign out link at the bottom. So we're just setting this to have overflow auto, and we're setting this inner wrapper here to have 100 VH or viewport height in order to make sure that this works and scrolls as you would expect it to. With all of that functionality out of the way and our proof of concept working, we need to make sure all this functionality stays tested and working. So we'll start to go over what we made progress with on the spec or unit test side of things. And I wanted to start in Database Cleaner here. One of my colleagues mentioned that Database Cleaner isn't needed anymore, and the way that it's handled now with the transactions in the database for the test environment just kind of works. So I commented all of our Database Cleaner config out here, and both the system tests and all of our unit tests passed. So I believe we can just remove Database Cleaner altogether. The first spec that we'll go over is the clip spec for the clip model. And I had Cursor generate these for me, and it's been something that I've been having relatively consistent success with, having Cursor generate new specs for me. It particularly works well if you already have specs written that follow the patterns that you like and everything, and just tell Cursor to emulate those patterns. It can go a lot quicker that way, but it's still something that you want to make sure you're going over every single line to make sure that they're not adding additional tests, which it does a lot of the times, or it's just not doing what you would expect it to. But this is what we landed on, and we're testing the associations, making sure that those streamer clips and streamers methods work on both of the clip instances that they're being used in. The validations here that we went over, so we're requiring a platform. We're making sure that stays the case. We're testing our scopes here, making sure that when we call our scopes on these models that we're getting the resources back in the order that we expect them in. The nested attributes area here, that goes over being able to use that nested attributes for method. And I don't think we went over that, so I can go over that now. Basically, in the clip model here, we just add the accepts nested attributes for method. We're specifying that on the streamer clips association, and it allows for this reject if hook here. And basically what we're doing is we're rejecting if all of the values for those nested attributes are blank, or if there's an ID present on the clip itself. So we only want this nested attributes to work if we're creating a clip from scratch. We don't want to open a gateway for anybody to use the nested attributes in an update call, because that would allow potentially streamer clips getting updated as well, and that's not the intended purpose here. So we're making sure that we're only using this if there's no ID. If there is an ID, it will not continue with the database transaction to actually update or save this record. So that's how you declare the nested attributes here. And then we just added a describe block to make sure that we're testing that as you would expect. And some more associations here that we probably don't need, but all of this is passing and we should be good as far as that goes. We also added a spec for this streamer clip, and this is going over very similar kind of concepts here. We're just using the RSpec kind of way of doing things here by declaring a model. All of the associations, validations, everything should be straightforward here. If you wanted to pause the video and take a look at some of these specs, feel free to do so to familiarize yourself a little better with it. But hopefully you get the idea of what we're trying to do here. These callbacks that we're using, so that like that valid before validation callback on the streamer clip, we're testing that here and making sure that that works as expected. The as JSON method, even though we're calling super on it, which will call the parent function that we're kind of overriding in that method there, we can still test it and make sure that it works, and everything will be displayed as expected when we call that method. And then Cursor created some edge cases here, which I figured out it seems to be, I find it fairly reasonable. Used it a few different scenarios where you're creating, maximum title lengths, and that works, and then exceeding the title length and not using a valid price. All of that is good stuff to test, I think, so that's fine. And I'm very much pro almost being verbose in testing. I think there are very few scenarios where you can have too much testing, and as long as you're not bogging down the entire test suite or writing redundant tests and that kind of thing, I always try to err on the side of safety with just writing another spec if it's going to capture the test of functionality that broke in the example of an edge case or something like that. We also added a streamer spec here that follows the exact same pattern with validations, associations, the single table inheritance stuff, making sure that it gets set up as a type streamer on the user class. All of that is the same. And then our clips system spec here, we're actually still in the middle of writing, but this is carrying right off from where we left from episode 2 with testing that the views all work. And this is where we'll test that the streamer clip cards get displayed in the correct order and everything like that. And it will follow the same convention that we did before using cupwrite and capybara. And that's going to be episode 3 in the books. We covered an incredible amount of ground today, from implementing the full TikTok iframe API to building out that public clip library system that is going to be crucial to the Klipshow MVP. Our hybrid Rails React ecosystem seems to be working well, and we continue to dial it in even further with those CSRF and Ajax and Toast implementations that we had to either refactor or adjust. We made sure to cover the ins and outs of all of our validations on the database level, making sure all new functionality that we've added is tested both from a unit perspective and a system test perspective. Next episode, we'll dive further into getting closer to building out the completed Klipshow MVP, which will start to deal with the streamer side of things in OBS and making sure that we have an endpoint that will work with having the streamer add a Klipshow view right in their OBS streaming software. And that's the part that I'm really excited about, because we'll start to look into that AnyCable and the necessary infrastructure to make that work, which is really exciting, and ultimately get closer to having this work, both from the streamer's dashboard side of things and the Twitch viewer side of things. Thanks so much for hanging out with me while I build out something that I've wanted to do for years. I've had nothing but good feelings about doing this, so I will see you definitely in episode 4 and beyond. Take care. I'm Johnny. We'll see you next time.